Let me introduce myself. My name is Renata Hudesoit, with NPM 2341161, Class Management 23C. Here I will explain about empirical model. The learning objectives of this material are understanding the form of empirical models, understanding analysis techniques, understanding variables in empirical models, and understanding the definition of variables. Then empirical model form. According to Giogianto, 2008, the form of empirical models can be grouped based on data values or scale values. The data value is divided into two, namely, 1. Metric data, which is data containing quantitative values, interval and ratio data types, and 2. Non-metric data, which is qualitative data that can be in the form of an attribute, characteristic or category or dichotomy, nominal and ordinal data types. Next is the form of empirical model. Empirical models can have more than one dependent variable. The empirical models that use one dependent variable are 1. Regression model equals y1 metric equals x1 plus x2 plus xn metric non-metric 2. Logit/Probit/Tobit regression model equals y1 non-metric equals x1 plus x2 plus xn metric non-metric 3. Discriminate analysis model equals y1 non-metric equals x1 plus x2 plus xn metric non-metric 4. ANOVA model equals y1 metric equals x1 plus x2 plus xn non-metric and 5. Conjoint analysis model equals y1 metric non-metric equals x1 plus x2 plus xn non-metric. Empirical models that use more than one dependent variable are as follows. 1. MANOVA model equals y1 plus y2 plus yn metric equals x1 plus x2 plus xn and 2. Canonical correlation model equals y1 plus y2 plus yn metric non-metric equals x1 plus x2 plus xn metric non-metric. Many empirical models use simultaneous equations, namely simultaneous equations and structural equation modeling. 1. Simultaneous equations equals y1 equals x11 plus x12 plus x1n, y2 equals x21 plus x22 plus xnm. Yn metric equals xn1 plus xn2 plus xnm metric non-metric and 2. Structural equation modeling equals y1 equals x11 plus x12 plus x1n, y2 equals x21 plus x22 plus xnm, yn metric non-metric equals xn1 plus xn2 plus xnm metric non-metric. Then variables in empirical models. A model is a symbolic form of a theory. Models that show causal relationships between variables in the model are called causal models. A variable is a symbol that contains a value. Variables are grouped into 1. Dependent variable, VD, 2. Independent variable, 6, 3. Moderating variable, VMO, 4. Mediating variable, VME, or mediating variable, and 5. Extraneous variable, VE, or extraneous variable. Next, analysis technique. According to Concoro, 2013, the analytical techniques used after determining the empirical model using multivariate analysis with the dependence method category include multiple regression analysis, discriminate analysis, canonical correlation analysis, and MANOVA analysis. A. Regression analysis. Concoro, 2013, defines regression analysis as a statistical tool. Regression is useful in answering the following research questions. 1. How far is the variation in changes in the dependent variable explained by all the independent variables included in the model? 2. Which of the independent variables affect the dependent variable? 3. Does the inclusion of one additional independent variable improve the prediction of the dependent variable? 4. Is the prediction of the dependent variable from a number of independent variables better than other combinations of independent variables? Next is the OLS method, largest quadrat step. The essence of the OLS method is to estimate a regression line by minimizing the sum of the squares of the error of each observation on the line. Next, inference of regression results. Concoro, 2013, suggests that a statistical calculation is called statistically significant if the statistical test value is in the critical area, the area where Ho is rejected. Conversely, it is called insignificant if the statistical test value is in the area where Ho is accepted. In regression analysis, there are three types of goodness of fit criteria, namely, 1. T-statistical test, 2. F-statistical test, and 3. Coefficient of determination. Then, individual significance test, T-statistical test. T-statistical test basically shows how for the influence of one explanatory variable individually in explaining the variation in the dependent variable. Simultaneous significance test, F-statistical test. F-statistical test basically shows whether all independent variables included in the model have a joint influence on the dependent variable. Coefficient of determination. Concoro, 2013, suggests that the coefficient of determination, R2, essentially measures how for the model's ability to explain variations in the dependent variable. The coefficient of determination is between 0 and 1. Discriminate analysis. Concoro, 2013, explains that discriminate analysis is used to achieve two objectives of discrimination and classification. So that we get the conclusion that discriminate analysis is a statistical technique for classifying individuals/objects into separate groups based on a number of independent variables. Canonical correlation. Concoro, 2013, canonical correlation analysis is an analysis or technique used to determine the level of relationship between two groups of variables, each of which consists of several variables. Canonical analysis is an extension of multiple regression analysis that focuses on the relationship between two groups of interval-scale variables. MANOVA analysis. Concoro, 2013, explains multivariate analysis of variance. MANOVA is the most commonly used multivariate technique. MANOVA describes the relationship between two or more dependent variables and classification variables or factors. Cluster analysis. Concoro, 2013, explains that cluster analysis is used to identify similar objects or individuals by considering several criteria. The purpose of cluster analysis is to classify mutually exclusive individuals or objects into a smaller number. Multidimensional scale. Concoro, 2013, explains that multidimensional scales are used as a technique for measuring objects in multidimensional space based on the similarity of respondents' assessments of an object. I think that's all and thank you.